हेलो स्टूडेंट्स, सो वेलकम टू टुडेज क्लास। आज जो हम चैप्टर करने वाले हैं वो है सॉल्यूशंस। डिस्क्लेमर: द images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the images. Next question: a solution of urea whose molar mass is 56 gram per mole, मतलब यूरिया का मोलर मास 56 ग्राम पर मोल है, boils at 100.18 degrees Celsius, right, at the atmospheric pressure. If Kf and Kb for water are 1.86 and 0.512 Kelvin kg per mole respectively, the above solution will freeze at. आपके ऑप्शंस है: A 0.654, B -0.654, C 6.54 डिग्री सेल्सियस और D -6.54 डिग्री सेल्सियस। तो इस क्वेश्चन में क्या गिवन है? बेसिकली इस क्वेश्चन में गिवन है कि हमारा जो सॉल्यूशन है ना, वो 100 डिग्री सेल्सियस पर बॉईल हो रहा है और ये चीज हो रही है एटमॉस्फेरिक प्रेशर पे, और हमारा KF और KB गिवन है नेक्स्ट, जो कि ये 1.86 और 0.512। हमें क्या निकालना है कि ये जो सॉल्यूशन है ये फ्रीज कितने पे होगा। तो इसका करेक्ट आंसर हो जाएगा बी, जो कि है 0.654 डिग्री सेल्सियस, राइट। तो क्वेश्चन के अकॉर्डिंग हम मूव करते हैं। पहले हम क्या करेंगे, डेल्टा टीएफ कैलकुलेट करेंगे, है ना। डेल्टा टीएफ क्या आएगा, KF इंटू एम हो जाएगा, ये हमारा जाएगा डेल्टा टीएफ। अब वैल्यूज पुट करते हैं। डेल्टा टीबी क्या हो जाएगा हमारा, KBM हो जाएगा, राइट। नेक्स्ट, तो इन दोनों सॉल्यूशंस की जो मोलैलिटी है वो सेम होगी, क्योंकि सेम सॉल्यूशन लिया गया है ना। तो हम लिख सकते हैं यहाँ इस इक्वेशन से, मोलैलिटी इज इक्वल टू डेल्टा TF बाई KF इक्वल टू डेल्टा TB बाई KB। सिंपल है। इसको हम क्रॉस मल्टीप्लाई कर रहे हैं और इस केस में इसको क्रॉस मल्टीप्लाई कर रहे हैं, तो हमें ये चीज पूरी मिल रही है। अब हमें क्या निकालना, हम इंटरेस्टेड है फ्रीजिंग पॉइंट में। हमारा बॉइलिंग पॉइंट ऑलरेडी गिवन है, तो डेल्टा TF हो जाएगा डेल्टा TB इंटू KF बाई KB। डेल्टा टीबी कैसे कैलकुलेट होगी, क्योंकि हमें तो टीबी गिवन थी ना, और टी नॉट भी हमें पता है, मतलब कि प्योर सॉल्वेंट वाटर की 100 डिग्री सेल्सियस होती है, ये चीज हमें पता है। तो हम डेल्टा टीबी आराम से निकाल लेंगे, 100.18 माइनस 100 विच इज योर 0.18 डिग्री सेल्सियस। तो ये हो गया हमारा एलिवेशन इन बॉइलिंग पॉइंट। अब इस चीज को हमने यहाँ पुट कर दिया फाइनली, तो क्या निकल के आई ये वैल्यू, 0.18 इंटू 1.86 डिवाइड बाई 0.512। तो ये वैल्यू कितनी निकल के आई, 0.654 डिग्री सेल्सियस। अब दिस इज नॉट योर आंसर बिकॉज दिस इज योर डिप्रेशन इन फ्रीजिंग पॉइंट, और हमें क्या निकालना है, हमें वैल्यू निकालनी है फ्रीजिंग पॉइंट की इस सॉल्यूशन के लिए। सो हमें पहले से पता है कि जो प्योर वाटर का जो फ्रीजिंग पॉइंट है वो है 0 डिग्री सेल्सियस, ठीक है, ये चीज हमें पता है। अब डिप्रेशन इन फ्रीजिंग पॉइंट को हम कैसे लिखते हैं, जो पहले का फ्रीजिंग पॉइंट है नॉर्मल माइनस जो सॉल्यूशन का फ्रीजिंग पॉइंट है। अब इस चीज को हमने पुट कर दिया, हमने निकाली थी वैल्यू, और हमें ये कैलकुलेट करनी है, जो फ्रीजिंग पॉइंट सॉल्यूशन की वैल्यू है वो हमें कैलकुलेट करनी है। तो वो कितनी निकल के आएगी, वो निकल के आएगी -0.54, -0.654, जो कि है -0.654 डिग्री सेल्सियस, ठीक है। तो दिस इज योर करेक्ट आंसर। सो रिमेंबर दिस, दैट दिस इज योर करेक्ट आंसर एंड नॉट यो डेल्टा टी एफ, राइट? क्लियर है ये चीज? बहुत अच्छा क्वेश्चन था ये। नेक्स्ट क्वेश्चन, if 0.1 molar solution of glucose and 0.1 molar solution of urea, okay, are placed at two sides of the semi permeable membrane to equal heights, then it will be correct to say that options are: A, there will be no net movement across the membrane. First, glucose will flow towards urea solution. Second, urea will flow towards glucose solution. Third, fourth, water will flow from urea solution to glucose. Okay. तो इस क्वेश्चन में क्या गिवन है? इस क्वेश्चन में दो सेम मोलर कंसंट्रेशन वाले सॉल्यूशन हमारे पास है, जो कि ग्लूकोज और यूरिया के हैं, ठीक है? और इन दोनों को हमने एक ही एक ही डिब्बे के अंदर दो कंपार्टमेंट्स में रखा है, और दोनों कंपार्टमेंट्स आपस में जो डिवाइडेड है वो एक सेमी परमेबल मेम्ब्रेन के थ्रू डिवाइडेड है ना? और हमने हाइट भी सेम रखी है। तो हमें क्या बताना है कि जो मूवमेंट होगा वो किस साइड होगा। तो करेक्ट आंसर इसका होगा कि कोई सा भी मूवमेंट हमें देखने को नहीं मिलेगा, कोई भी नेट मूवमेंट हमें देखने को नहीं मिलेगा। हो सकता है कि डायनेमिकली चीजें हो रही हो, पर ओवरऑल जो मूवमेंट होगा वो क्या होगा? वो जीरो होगा। सो नो नेट मूवमेंट अक्रॉस द मेम्ब्रेन। ऐसा क्यों होगा? क्योंकि ये दोनों जो सॉल्यूशंस है ना, वो आपस में आइसोटोनिक है। सो दिस सॉल्यूशंस आर आइसोटोनिक। क्यों आइसोटोनिक है? क्योंकि ये सारे की सारी जो प्रॉपर्टीज है, हमें पता है कि ये कॉलिगेटिव प्रॉपर्टीज है। इनकी जो वैल्यूज है वो किस पर डिपेंड करती है? वो सिर्फ और सिर्फ कंसंट्रेशन पर डिपेंड करती है। तो क्योंकि हमने कंसंट्रेशन सेम रखा था क्वेश्चन में, ये देखो कंसंट्रेशन सेम रखा था, इसीलिए ऑस्मोटिक प्रेशर की वैल्यू भी क्या आएगी? सेम आएगी। पाई इज इक्वल्स टू सी आर टी, सी सेम है तो पाई भी सेम होगा। आर और टी तो पहले से ही कांस्टेंट है। तो इसी कारण से क्या कि ये कॉलिगेटिव प्रॉपर्टीज है, जो कि नेचर पर डिपेंड करेगी, सिर्फ अमाउंट पर डिपेंड करेगी। और हमने जो अमाउंट है वो सेम ले लिया है, इसीलिए हमें कोई सा भी नेट मूवमेंट देखने को नहीं मिलेगा सॉल्वेंट या सॉल्यूशन की तरफ से। क्लियर है? ओके। नेक्स्ट क्वेश्चन, which one of the following salts will have the same value for Vent of factor, that is uh, I, as that of K4FeCN whole 6? तो इस क्वेश्चन में क्या बताना है? इस क्वेश्चन में बताना है कि ये जो चारों जो सॉल्यूशन जो आपके ऑप्शंस थे, उनमें से किनका आई फैक्टर इस कॉम्प्लेक्स के बराबर होगा। ठीक है, तो करेक्ट आंसर होगा इसका ए, जो कि है Al2SO4 होल थ्राइस। So K4FeCN6 and Al2SO4 whole thrice will have the same Vent of factor. क्यों? क्योंकि दोनों डिसोसिएट होकर हमें 5 आयंस देते हैं। ठीक है, और जितने नंबर ऑफ आयंस ये हमें देंगे, और ये दोनों के दोनों क्या है? कंप्लीटली डिसोल्यूट हो रहे हैं, इसीलिए इनकी आई की वैल्यू क्या है? 5 है दोनों की। ऐसा कैसे हो रहा है? तो पहले हम बात करते हैं इसकी। तो ये जब हम इसको वाटर में डिसॉल्व करेंगे तो इसकी प्राइमरी वैलेंसी क्या है? आयनाइजेबल है, इसलिए वाटर में डिसॉल्व हो जाएगी। सेकेंडरी वैलेंसी क्या है? एज इट इज रहेगी इसमें। ठीक है, ये चीज क्लियर है। अब दूसरी चीज क्या होगी? दूसरी चीज ये होगी कि ये भी जो हमने जिससे हमने कहा कि ये इसके बराबर होगी, उसका भी अगर आप देखो तो ये किस में डिवाइड होगा, ये डिवाइड होगा आपके 2Al3+ में। ठीक है, Al2 जाएगा, एक Al पे होगा 3+ का, तो 2Al पे, तो 2Al हो जाए यहाँ पे। ठीक है, तो 2Al3+ हो गया, और सल्फेट आयन भी 3 आ गए, तो 3+2 5 होगा यहाँ पर, 4+1 5, मतलब टोटल नंबर ऑफ पार्टिकल डिसोसिएट करने के बाद दोनों में सेम अमाउंट के बन रहे हैं। तो ये चीज क्लियर है। तो इस चीज के लिए आपको जो चीज आनी चाहिए वो ये है कि प्राइमरी वैलेंसी आयनाइजेबल है। ठीक है, सो हमारा करेक्ट आंसर कौन सा हो गया, Al2SO4 होल थ्राइस, है ना। नेक्स्ट क्वेश्चन, formation of a solution from two components can be considered as one pure solvent moving on to separated solvent molecules delta H1, two pure solvent moving on to separated solute molecules delta H2, and three separated solvent moving on to solution delta H3 and solute molecule. Solution so formed will be ideal. In which case your options are A, delta H solution equal to delta H3 minus delta H1 minus delta H2. Option B, delta H solution equal to delta H1 plus delta H2 plus delta H3. Option C, delta H solution equal to delta H1 plus delta H2 minus delta H3. और ऑप्शन डी है डेल्टा H solution equal to delta H1 minus delta H1 minus delta H2 minus delta H3. क्लियर है। इस क्वेश्चन में पूछा क्या गया है, इस क्वेश्चन में पूछा गया है कि हमने ना तीन तरह के प्रोसेस किए। पहले हमने प्योर सॉल्वेंट लिया और उसको सेपरेट कर दिया सॉल्वेंट मॉलिक्यूल में, उसके लिए कुछ एंथैल्पी चेंज हुआ, उसको हमने डेल्टा H1 मान लिया। फिर हमने प्योर सॉल्वेंट लिया और उसको क्या कर दिया, हमने सॉल्यूट लिया और उसको हमने क्या कर दिया, सेपरेट कर दिया सॉल्यूट मॉलिक्यूल्स में, और इसके हमने क्या माना, इसके लिए हमने एंथैल्पी चेंज मानी डेल्टा H2। फिर हमने सेपरेटेड सॉल्वेंट लिया और उसको सॉल्यूशन बना दिया, तो इसके लिए हमने डेल्टा H3 मान लिया। तो हमें बताना है कि इनमें से कौन सा जो कॉम्बिनेशन है वो सही होगा। ठीक है, तो जो आंसर गिवन है वो ये है कि जो ओवरऑल डेल्टा एच सॉल्यूशन है वो इन तीनों का एडिशन होगा। क्यों, क्योंकि डेल्टा एच मिक्सिंग क्या होती है, जीरो होती है। ठीक है, डेल्टा एच मिक्सिंग क्या होती है, आइडियल सॉल्यूशन के लिए जीरो होती है। और अगर ये जीरो होती है तो मिक्सिंग के समय कोई भी चीजें नहीं होगी, मतलब कि आप प्योर सॉल्वेंट को अगर बात करें, अगर उसके उसके पार्टिकल्स को अलग करो और प्योर सॉल्यूट के पार्टिकल्स को अलग करो, और जो तीसरी चीज क्या है वो है कि सॉल्यूशन बनाओ सेपरेटेड सॉल्वेंट से, तो उन तीनों की जो इंथैल्पी चेंज होगी उनका एडिशन क्या होगा, डेल्टा एच सॉल्यूशन के बराबर होगा, है ना। मतलब कोई पार्टिकल के बीच के इंटरेक्शन के कारण इंथैल्पी चेंज में नहीं आएगा। ठीक है, चाहे आप सॉल्वेंट कर लो, चाहे सॉल्यूट कर लो, चाहे सॉल्यूशन कर लो, तीनों केस में जो इंथैल्पी चेंज आएगा वो सेम आएगा। और इसी केस से अकॉर्डिंग टू हिसेस लॉ हम ये इक्वेशन लिख सकते हैं। ठीक है, so for ideal solution there is no change in magnitude of the attractive force in the two components present. So this is your answer. Correct. 1 molar solution of sodium chloride has a density of 1.21 gram per ml. The molarity of this solution is, your options are A 4.15 molar, B 1.143 molar, C 2.95 molar, and D 3.15 molar. Now what you can do in this question, what will be the hint for this question, that your molality is given and your density is given, so you can use the molality thing to calculate the volume. Okay, because molality is what, it is basically the number of moles of solute per kg of the solvent, right, not the solution, solvent. So using that mass of solvent you can calculate the you can calculate the volume, because density is already given. So this much hint is more than enough to solve this question. So what was the question, the question was saying that Your 1 molar solution means the molality is 1 mole, has a density of 1.21 gram per ml. So you have to find the molarity of the same solution. Now for those who have solved, the correct answer is B. First of all, we will calculate the molar mass of NaCl. Okay, because this is given, it is of sodium chloride, so 58.5 grams. So you can use the formula directly also, which is m is equals to, which is molarity is equals to m into d by 1 plus small m into m2 by 1000, where m2 is what? M2 is the molar mass of NaCl. If you put all these values, you will get your molarity is 1.143. Clear? Now what is the other thing that you can use? First you can just find the volume, so that will give you the same solution, right? So first you can find the volume of the solvent. Okay, first you can find the volume of the solvent, right? So that is simply your density multiplied by the what? Density multiplied. So this is of the solution. This whole thing is of the solution. Okay, so how you can find the volume of volume related to this mass? So it is already given that 1 kg of that solvent contain 1 mole of that substance. Now 1 mole of the substance means 58.5 grams of NaCl. Clear? So convert this mass of water into grams. So that will give you 1000 grams. So 1000 gram plus 58.5 grams is the what? It's the mass of the solution containing 1 mole of NaCl. Fair enough. Now you can use that 1000 plus 58.5, which will give you 1058.5, to calculate the volume, because this is your mass. So mass per unit volume is density. So volume will be mass by density, that is 1058.5 multiplied by divided by sorry. So mass density is equals to mass per unit volume. Therefore, volume is equals to mass, that is 1058.5 by 1.21. So that will give you what? That will give you your volume. Clear? Now again molarity is going back to that thing, which is 58.5. So 58.5 by that thing will give you your molarity. Clear? So the main hint for this solution will be two things. So okay, for two types of solution will be two things. First, you can use this formula directly if you are good enough to remember it. If you are not, just remember the concept that 1 molar solution means 1 mole of NaCl is there in 1 kg of water. So therefore total mass of solution containing 1 molar of NaCl is nothing but mass of water plus mass of 1 mole of that substance, that is 58.5 and 1000 grams. Clear? Now use that volume to find the say sorry, use that mass to find the volume using the density, and at last just keep the number of moles on the top and divide it by the volume to get the molarity of the solution. Clear? Now moving on for the density in gram per ml of 3.60 molar sulfuric acid having 29% H2SO4. Okay, by mass will be, your options are A 1.64, B 1.88, C 1.22, and D 1.45. So again, what will be the hint for this question? So you have to find what? You have to find the density. Okay, density you have to find, and molarity is given, and what is given else? Your uh, mass percentage is given. So mass percentage means this is the solution of sulfuric acid. Therefore, if you are taking say 100 grams of the solution, then it contains 29 grams H2SO4, and the rest of the mass, that is 100 minus 29, is the mass of the water. Clear? Fair enough. So you're given the molarity first of all. So molarity will be equals to what? Number of moles, right? Number of moles by given volume, right? Given volume. So you don't have the volume here. The problem is that you don't have the volume here. You can find it using the density. So use this thing, right? Just use this part to calculate the overall value. So your time to solve this question starts now. part. So this was your question. I have already explained it to you. A short question. You don't need any more explanation, I think. For those who have solved it, the correct answer is C. Now we can use this formula directly, which is molarity is equal to 10 multiplied by density by percentage of weight of the solid multiplied the percentage of weight of the solid by molecular weight of the solid. If you put all of this 3.60, 98, 10 and 29, then you can calculate your density, which will come out to be 1.216 gram per ml. Okay, or you can just round off it to 2 decimal places, which is 1.22 gram per ml as your correct answer. Now moving on to the next question. The molarity of the solution obtained by mixing 750 ml of 0.5 molar HCl with 250 ml of 2 molar HCl will be. Your options are A 1.00, B 1.75, C 0.975 and D 0.875. So what will be the hint of this question? So you will use the formula directly, or you can else what you can do, you can calculate the number of moles, millimoles I would say, related to this solution and related to this solution. Then you can divide by the total volume, which is this plus this, and hence you can easily get your molarity, or else you can use the formula directly. So I will not tell you the formula, that is up to you to get. Okay, so this was your question. So in question, what are you doing? You are mixing two types of solution together, and then you have been asked that what is the molarity of the resulting solution. So for those who have solved, the correct answer is D. So this is the formula, M1V1 plus M2V2 gives us the total number of moles, right? And molarity is the total number of moles divided by the total volume, which is 750 plus 250. Now putting all these values, 0.5 into 750, okay, total number of millimoles, and 2 into 250 divided by total volume, which is 1000. Now you will say that why don't you convert this milliliter into liter? Because on the upside and downside, if you multiply it by 10 to the power 3 to get this millimoles to mole, and then you have to also multiply this total volume to into 10 to the power 3, that will at last get cancelled out. Now for that reason we don't need to do it. So the molarity comes out to be 0.875 molar solution. Moving on to the next question. 10 milliliter of 2 molar NaOH solution is added to 20 milliliter of 0.5 molar NaOH solution. What is the final concentration? Options are A 0.75, B 5.7, C 11.4, D 1.14. How you will solve this question? So you can do it in two ways. Either you can use the formula directly. So I will not tell the formula. That is up to you to get. Now for those who are not going through the formula but through a conceptual way, what they can do is first calculate the millimoles related to it and divide it by the total volume, and then you can easily get a molarity. Now you don't need to convert this millimole into your moles, because we are dividing the means you are dividing the millimoles by volume, which is already in milliliter. Okay, so you don't need to do so. It will get cancelled out at last. So the question was saying that you are dissolving two types of solution, which is this, and you have to find the molarity of the resulting solution. For those who have solved, the correct answer is A. So final concentration is simply they have used the formula directly, M1V1 plus M2V2 by V1 plus V2. Clear? And that will directly give you answer, which is 0.57 molar solution. Clear? Now moving on to the next question. The density of a solution prepared by dissolving 120 grams of urea in 1000 gram of water is 1.15 gram per ml. The molarity of the solution is, options are A 0.50, molar, B 1.78 molar, C 1.02 molar, and D 2.05 molar. So the density of the solution is given, which is 1.15 gram per ml, and you have to find the molarity of this solution. At the same time, it is already given that 120 gram is being dissolved in 1000 gram. So what will be the hint of this question? So the hint of this question will be that you can find the volume using the total mass, because density is already given. Clear? Solution. So question was already discussed that you are given the density and you are given the amount of what amount of what is dissolved in say solvent in terms of gram, and you have to find the molarity of the resulting solution. For those who have solved, the correct answer is D. So total mass of the solution will be given by 1000 gram plus 120 gram. Okay, that is 1120 gram. Therefore, density of solution can be used to calculate the volume, which is mass by density. Now, if you put these values here, you will get this as 0.974 liters. So this is the what? This is the volume of the solution. And in this volume, 120 gram urea is dissolved. Therefore, you can find the moles of urea, which is 120 by 60, which is 2 moles. Okay. Now you have the moles of the solute, you have the volume of the solution. Put all of this in this standard equation. So that will give you 2.05 mole per liter as your correct answer. Clear? Okay. Now moving on further to the next question. The density of 3 molar solution of sodium chloride is 1.252 gram per ml. The molality of the solution will be. Your options are A 2.60 molar, B 2.18 molar, C 2.79 molar, and D 3.00 molar. So what is the hint of this question? The question is saying that the density of 3M solution means the molarity is given, okay, and density is given. So you can use the formula directly, which is say relating your density, your molar mass, and your molarity, or else you can go it conceptually. You can go through it conceptually also. How can we do it? So the density is given, right? So and your molarity is given. So from this you can calculate the mass of the mass of the solution, and then you can subtract the mass of the solute, and where we will calculate it from number of moles. If you subtract it, you will get the you will get the mass of the mass of the solvent. Clear? Okay, and now your moles are already been defined, so hence you can use this to find a correct answer. So this was your question. So it was saying that you are having 3 molar solution whose density is 1.252 gram per ml, and you have to calculate the molality. Now for those that solved, the correct answer is C. So 3 molar solution means 3 moles of solute in 1000 ml. Okay, clear? So mass of the solution is volume of solution into density. We know that. So that will give you mass of the solution. Now what do? We calculate the mass of the solute, that is number of moles into molar mass of NaCl. Okay, number of moles into molar mass of NaCl. So number of moles is what? It is given 3. So 3 multiplied by 58.5, which will give you the mass of solute. Now subtract this solute mass from solution. So we have get this 1.076 kg. Therefore, molarity is nothing but moles of solute. We have already seen it by mass of solvent. So that will give you 2.75 molar solution. Clear? Now moving on to the next question. A 5.2 molar aqueous solution of methyl alcohol is supplied. What is the mole fraction of the methyl alcohol in this solution? Your options are A 0.100, option B 0.190, C 0.086, and D 0.050. So you're given what? You're given the molality and you have to calculate the mole fraction. So what do we need? We need the say number of moles of the solvent, because number of moles of the solute is already given, and we know the mass of the solvent because it is 1 kg. So if 5.2 moles are this methyl alcohol dissolved in 1 kg. So this 1 kg can be converted into what? So you can use this 1 kg to get your molar mass and then your number of moles. Clear? So your time to start this question starts now. Part. So the question was saying that you have a molar solution, 5.2 molar solution of CH3OH, and you have to find the mole fraction. Simple question. You don't need to go through any complication. For those who have solved, the correct answer is C. Okay. Now, what is molality? It is moles of solute by mass of the solvent. Clear? Moles of solute by mass of the solvent in kg. So that will using that you can put all of this 5.2 into 1 kg. Okay. So that will give you moles of CH3COH 5.2. Now from here you can calculate the moles of water also, because we know that in 1 kg you have 1000 gram, so 1000 by 18. So that will give you moles at 55.56 mole. Now how will calculate the mole fraction? To total number of moles N1 plus N2, which is 60.76, and the mole fraction of CH3OH will be number of moles of CH3OH will be 5.2 by 60.76. That is 0.086. So one thing is there that what you have to remember about this question is that since you are being given the molality, you should know its definition exactly. Then you can use this part efficiently to solve all questions. If you don't need remember the exact long formula also, you can use the basics behind it to get an answer. Clear? Okay. Now moving on further. Question number 25 ml of a solution of barium hydroxide on titration with 0.1 molar solution of hydrochloric acid give titre value of tighter value of 35 milliliter. The molarity of barium hydroxide solution was, your options are 0.07 molar, B 0.14 molar, C 0.28 molar, and D 0.35 molar. Clear? So what you have to do? You have to do titration. Okay, you have to do titration. And how you will do titration? So in titration, you should be neutralizing the amount of what? Hydrochloric acid, which is 0.1 molar 35 ml. So from here you will calculate the number of moles. You will equalize it. Okay, you will equalize it with the number of moles of barium hydroxide, as you know the volume, but the number of the molarity is not known. So but you have an equation and you have all of the things. If you put there, you will get the equation. So it is being said, right? It is being said that you have to neutralize this whole thing of 25 ml of barium hydroxide, sorry, 35 ml of hydrochloric acid having 0.1 molar solution. So you are given a 25 molar solution, so you require 25 ml solution. So you have to calculate the molarity. Okay. Now for those who have solved, the correct answer is A. So if you just calculate the normality, then it will be N1 M1. Clear? And what about the normality of HCl? It is N2 M2. So N1 V1 is equals to N2 V2 for complete neutralization. So keeping this thing here, N1 M1 V1 to N2 M2 V2. So what is N for VaH2? It is 2. Volume is given. For this HCl only one H plus is present and volume is given and molarity is given. Now from here you can find the molarity of the beryllium hydroxide. So that will give you 0.07 as your correct answer. Clear? So this was all for your today's question session. Thank you.